Hello everybody, we're going to be talking about the triangle proportionality theorem today. Real quick before I even start, I'm just going to apologize for this scribble right here. It's because this is like the fourth time that I wrote this and I wrote it wrong all four times. So instead of rewriting the entire page again, I just scribbled it out. So, anyways, here we go, triangle proportionality theorem. Here's what the theorem says. It tells us that if we have line segment DE in a triangle, here it is, DE, and it's parallel to one of the sides, right here happens to be BC, so we see that these two are parallel, then two things happen. One thing is that we get similar triangles. That should make sense because here's the triangle, and we're making a line right here that's parallel, so we're going to end up having congruent angles here and here, and we're sharing an angle which makes them congruent. So we clearly have the congruent angles part. The other thing that we got to be concerned about, though, would be the proportional sides. Well, what the triangle proportionality theorem tells us is that as long as these sides are parallel on these two triangles, we automatically get proportional sides. And even cooler is that we can make our comparison along just the pieces here. Remember last time we had to compare side to the entire length. Side to the entire length. What this theorem does now is allows us to look at just pieces of triangles. Okay, so we're going to end up writing our ratios a little bit easier for these problems. Okay, so let's take a look at a couple of examples. Here's the first one. We notice that we have two parallel lines and we have information given throughout. Well, I can set up my first ratio comparing the side length of 15 compared to x, and I'm going to set that equal to this piece right here. Oh, wait a second, I'm missing a value, aren't I? That's easy enough to do. Remember, our subtraction works pretty well. The entire length here is 14, this small piece is 4, so 14 take away 4 is going to leave me with 10. So my length here is 10. I'm going to compare it to this littler length of 4. And let's reduce when we have the chance. That reduces to 5 over 2. Let's do some quick cross multiplication. X times 5 leaves me with 5x. 15 times 2 gives me 30. If I divide by 5 on both sides, that gives me 6 for my missing side length. Okay, so again, not difficult stuff. It's just setting up the ratios that's going to be tricky. And if you can remember that we can just compare this piece to the other piece on the same side, set it equal to the piece compared to the same piece, or the other piece on the same side, our ratios should be set up with no problem. So I want you to try this one on your own. Take a second to pause the video and then resume it when you're ready. Alright, let's see how you did. Might be a little bit blurry, I'm sorry if it was, but that's a 20, that's an 8x, and 18. So we see that we have parallel sides, we have the pieces already given to us, all we have to do is set up our ratio. So I'm going to set up 20, this piece, over the same side, the other piece, which is 8. I'm going to compare it to x over the other piece on the same side, which is 18. And before I do too much work, I'm going to reduce. This reduces to 5 over 2. Both numbers are divisible by 4. And then I'm going to cross multiply. 2 times x is 2x. 5 times 18 is 90. Divide both sides by 2. I find x to have a value of 45. Hopefully you got that one correct. We have a couple more examples to look at. Alright, now nothing really different is happening in this example. Sure, you might notice that instead of just an x, we have a 5x, but that's not going to change anything. We're still going to write a ratio, and we're still going to set up the proportions, cross multiply, and everything else. So let's just do what we're supposed to for this problem. Well, I notice I have 5x as a smaller piece, and the entire length is 45. So what I'm going to do is I'm going to take this piece right here, and I'm going to write it as 45 minus 5x. That's going to give me just this small piece that I need. Okay. Over here, I have a length of 20, a full length of 36. So if I take 36, subtract 20, that's going to give me a length right here of 16. Now I can set up my proportions. 5x is compared to 45 minus 5x. That's going to be equal to 20 over 16. And if I can reduce, I will. Both of these are divisible by 4. That's 4 over 5. Something you might not be quite good at recognizing at the moment. I have 3 numbers on this side of my equation that are all divisible by 5. So I actually can reduce this. So if you can catch something like that, I would if you can. If you're not quite there yet, it's not a problem. This just changes into x over 9 minus x, because all 3 things when I divide by 5. And I'm going to rewrite this other side so we can see it a little bit better. Okay, again, it's still going to give you the right answer if you don't recognize that reduction, so don't stress it if you didn't see that right away. You'll still get the correct answer. We're going to cross multiply like normal. It's going to give me 4x on one side, equaling, well, I got to distribute, so this is going to be 45 minus 5x. I want to add 5x to both sides. It gives me 9x equals 45. And my last step, to divide by 9, gives me a solution of x equals 5. So, again, what's really important with this problem is that you recognize first that we have these parallel lines and that we can start comparing piece of one side to the other piece of that side and set it equal to this piece compared to the other piece on the same side. Once you have that ratio set up, it doesn't matter if you reduce necessarily. You can still do all the same cross multiplication. You'll still end up with the same answer. Can you recognize the reductions? That's something that needs a little practice to do. So here's a final problem for you to try. Pause the video, test it out on your own, and then resume it when you're ready. Alright, let's see how you did. First thing we got to deal with is this piece KL. Well, if I have 8 and the entire length is 24, that means that this little piece right here has to be worth 16. And now I'm going to make my ratios. I'm going to compare 8 to 16. I'm going to set that equal to, well, I have a piece right here of x plus 5. And I'm going to compare it to 6x plus 2. We've got a bit of cross multiplication going on here. This is going to give me 16x plus, well, 5 times 16. That's 80. And on this other side, I have 8 times 6, which is 48x plus 16. Have to do a little bit of subtraction. That leaves me with 80 equals, let's see, 48 minus 16. That looks like 32x. Subtract 16. Oh. 64 equals 32x. Ah, this is looking pretty good. If I divide by 32 on both sides, that leaves me with x equaling 2. Hope that you got that one correct. Again, all we're doing is looking for the value of x, and if we set up our proportions properly, we should be able to do all this algebra. Might take us a little bit of extra time, but hopefully you came up with x equaling 2. That's it for the triangle proportionality theorem. If you have any questions on this, again, leave them on the website or bring them into class, and we'll answer them there.